Hi guys, and welcome to this video on how to build a machine learning script that does stock prediction using Keras and Scikit-learn. So in this video, we'll cover how to build a machine learning script that uses the data frame that we've been creating in the previous video to predict whether the value is going to be 1 or 0, which is either the price will go up or down. So the first thing is to do the imports here, which are mainly Keras and its dependencies, pandas, Scikit-learn, which is going to just split the data using train test split, NumPy, and accuracy score, which is just going to take the prediction value given out by Keras and gives it as a accuracy score, which is usually 1 being the equal of 100%, and point something like 0.9 is the equivalent of 90%. Some other Keras dependency like LSTM, which I don't think we're using here, Scikit-learn import preprocessing, and random forest classifier, which is for Scikit-learn. Okay, so let me just see if that went on okay. Let me just first start this so that the numbers actually all start at 1. Okay, I think I told it to just run the whole thing from the beginning to the top. So anyway, so now we have the imports done. Okay, let me just restart it so at least go step by step. So now the imports are complete. You can tell here by using a TensorFlow as backend. The next step here actually now is a function that I'm going to be using to split the data frame to an X and Y. If you've done machine learning before, you usually split your database into X and Y, X being the training, Y being what you want your answer to be. Like for example, in this case, you're giving it data and asking it, is the price going to go up or down? So that will be called a binary classification because you're only giving 2 answers, up or down. And there are regression models which will tell you, given what you've told me, the next price is actually going to be this figure. I think that one is just more of a stretch and it's a lot harder to find. Mine, I'm just going to go with a simpler analysis. Is the price going to go up and down? That's all I need to know. And then it's up for some additional analysis to figure out what's your best guess on how much it's going to go up and down. Is it extremely, a little bit extreme, or extremely not? So basically, if it's going down and the answer is extremely, it's going to go down extremely. If it's going up and the prediction is also extreme, it's going to go up extremely. So that's the idea of how I had this in mind. So with this one, the next thing I'm going to do is use the data frame for Bitcoin USD to train this model. You can see here, this is just the same hair that you had in the last time. I'm also going to show you the tail here because in the next video we're going to be harvesting some data and using it to recheck whether the classification accuracy persists over time. And as you can tell, the last row in the data frame, the date is 2018-08-20, which is August 20th. Okay, so here I'm just also going to load another data set for EOD MSFT. And I'm going to use the first data set from Bitcoin and divide it into X and Y by just specifying the rows and using dot values. So I just get a list back of the values. Then I'll use train test split to split X and Y to 80% test, 80% training, 20% test. That's actually what test size means, and 0.20 means 20% goes for the test training. And random state just means if you do this split any given time, you're actually going to get the same amount, the same ratio of split, the same order, in the exact same order. But if you don't want the split to come in the same order, You just remove random step and basically it splits it randomly. This can actually be good if you actually want your machine learning script to be basically you want it to be a bit more predictable. For example, if you're doing a cat and dog analysis, image analysis, and your image classifies dividing your database into cats and dogs, splitting them and then arranging them randomly, because your classifier will just be getting images in random order and learning through them, your accuracy may vary. It should not vary by a huge amount, but a small amount. And that small amount may be, even with tweaking, become harder for you to see a pattern, because you may try something that is good, but there's a small amount of shift because it didn't pick up something useful as it did the first time. So that may help in scenarios where your data is really volatile, in the case of image classification. But since this case it's not really that volatile, and more importantly, I feel the date arrangement, this is why I'm also doing the test split. I could have just done just pick out the values and randomly split them from get the length and then just split from the beginning to the end, but the order shouldn't really matter because you're given a range of numbers and I want to know, is it going to go up and down? That randomly rearranging things makes it even harder to kind of try get used to the idea that maybe in the beginning Bitcoin usually had a free run of a slow amount of growth, then a huge growth, then slowly going down. So you may get used to the beginning, really expect things will go up, and then in the end really expect things will go down, which is just not really the best method. But this one would actually be just randomly divided, shifted, so it'll have to do a lot more work to actually see the pattern in the data that's given. So using Scikit-learn's a classifier which is called random forest classifier, which I found has the best classification accuracy. Let me just run that, show you how it does. So what it just tells you back is, here's your classifier and here's what you get back. Just to tell you a little bit about what a random forest classifier is. A forest classifier is more of a tree figure. So basically, to give you an example in this case, if you are to give a model an example of houses, and it was supposed to predict the price of the house, and you give it a lot of information about the house, like the color, how old it is, how many rooms it has, and so on and so on, the location and so on. Just basically as much information about a house and your estimation about the price. So if your house's prices are usually more or less constant, for example, let's say in a more suburban area they have a constant area, and a more rural area they're more cheaper in that scenario. And depending on the size, whether it's a 1-bedroom, 2-bedroom, bungalow and so on, they have a constant feel to it. Some other additional feature, like let's say you have a backyard, swimming pool or something, those features is a random forest classifier. So basically it has a tree-like figure. It's asking itself questions. Do you have 1, 2, 3, 4? If you don't have this one, based on like a basket scenario, it says basically things which have this number of baskets tend to have this price, and these ones have this price. So it always put things in a basket. And in this case, since we have only 2 baskets, 0 and 1, it just looks for as many interesting things and then just branches them into a tree-like figure. Unfortunately, I can't show you how the tree looks with Scikit-learn for now. I haven't actually found out if it's possible. What I can actually just show you is the accuracy. And the interesting thing is, usually this accuracy is usually spot on the same. So like if I run this again and show you the accuracy, now it's 0.9401, and look at the last figure, it's 264. It's exactly the same. So basically the way it splits its trees it does the exact same logic of looking for paths, and gets to such a high degree of looking for what makes something actually be classified as this or that I believe this one was the best. And yeah, if you actually do find yourself using random forest classifier, you will be impressed by the fact that rerunning the script, I think, I'm not sure if you remove random state, it will give you a different arrangement, but in that case, we're actually giving data in the exact same order, it will give you the exact same result. Unlike dense models using Keras, which will be very close, but there'll always be a little bit of a shift in the accuracy. So the next step I'm just going to do is import job.lib and save the model as a pickle file. So this is now the finished training model that has this 0.934 classification, and anytime I want to use it, I can just load it in like this, and then this is a number of values that I got somewhere up here. As you can tell here, you have just scroll a little bit up so I can show you. We have 1, 2, 3, 4, 5, 6, 7 values, which is the same as here, which is usually created by the value list, which is 1, 2, 3, 4, 5, 6, 7. So I just copied one of these values beforehand, pasted them here, just to show you how you basically feed one of these as an example and train it. You just do clf to predict mp.array, so basically turn this list into a numpy array, reshape it into 1 to -1, 1 comma -1, so basically it can actually work with multiple arrays. So you're telling it this is an array which only has one row inside of it, and then 0 is just getting the prediction of the first object, the first only the first one that you got. And with that, you can see the answer for that. Now you can actually also, using the same logic, at the top here, you actually believe it's still the same thing, clf score x test y test, just to check the accuracy. So let me just remove that, and these are just all the rows that are available, because df.ilog just shows you, yeah, this is actually how I got all of this, if I'm not wrong. Basically, it's just one way to do this. I believe if I run this, I will get the same figures. Yeah, okay, just as an, by the way, if you actually wanted to copy that, this is actually how you just look for one example of the figures that you wanted to work with. I believe in this case, because this data frame actually, as you remember, we actually did a little bit of editing at the beginning up right now, so it may actually not have the exact same first date as it has right now. So anyway, if you actually are interested in just picking a date from anyone or any point in your data frame, df.ilog, and ilog actually just means which row. So 0 means the first row. You can just go on up to whichever row you're interested in. Like, let's say for example 10. Find the values there. So if you're just interested in the values only, I'm not sure if to list works here. So you can just do like this, to list, and I believe this one may actually have up to the actual value, which is the 7th value, and one more, which is the date. So let me just copy and paste this. So with this in mind, if you actually wanted to do this in the same way, you just start with from position 1, which is ignoring date, and you want to ignore also predict, I believe, and actual. So this is, you want value USD, max 7, minimum 7, min 7, change mean drop and drop 7. So I believe here we actually just send in 7 values. And if you're interested how I actually pick them out, it will be this this list, which actually may work if we specify it as a additional field to the iloc. So let me try this. So it gives them back. Can do it just the more logical way, this way. And then yeah, so now you have all the 7 fields that you'd be interested in using. Just turn that to list, and you have your list of values to train your model with. Basically just do a random example with. And now the next step will be, I wanted to now try this with another model. So I'm creating x2 and y2, running this on now CLF2 using x2 and y2, and you can tell here the accuracy is even a little bit higher than it was here, but here we're actually running it. Let me just show you where this came from. X2 and Y2 come from dataframe 2, and dataframe 2 is from EOD-EMST edited. So these are 2 different data frames using the same CLF classifier. And the first one gave an accuracy of 93%, and this second one gives you an accuracy, or the first one gave you an accuracy of 93%, this one gives you an accuracy of 96%. 2 different data frames, but it's still getting over 90% accuracy. Both of them was almost close to 95. One is over, one is just slightly below. And one thing that you can I wanted to actually show you as another example is, what if you actually wanted to use Keras, which has deep learning, or well, not technically deep learning, it's called CNN, which is convoluted neural networks, which are layers of dense layers stacked on top of each other, which Scikit-learn doesn't do that. And in most cases, in some models, it actually gives it better accuracy. So you may be curious to wonder, if you did this with a machine learning script, what would be accuracy that you'd be getting. So the first thing I did here is drop the date from the first data frame, which is for the Bitcoin. Remember, this is important because I'm actually not going to be using the date when predicting. The date isn't actually important. The model isn't going to be using that to determine what's going to happen. And using that 2xy model as a function I showed you at the top, I'm going to feed it the data frame and tell it, look for the field actual. So what it actually does is, for all of these columns, everything else is the x value, and the one that you specified here is now the y value. So it just basically splits your data frame into 2 groups, x and y. And so the next thing you just do is do a x train y train split, and then using this model setup, which is just the more normal way of doing this with our Keras. And I went with a little bit of a stagnant straight looking model at the beginning, but let me just undo that. Usually one way of making this a little bit better is what's seen as a tree figure. So basically it grows as it goes down. So let me say here the lowest level is about 50, goes to about 80, then comes 100, then it becomes 120. Let's say that's the model of how I'm going to be training this, and all you just need to do is just run it, see what happens. Y train shape 1. Okay, so this is actually an issue with shaping the model. So how it's trained, yeah, Y train shape dot 1. So somehow it's not actually getting I'm just going to put one because basically it's just a soft marked activation or soft marks activation, which is usually just going to be 1 or 2. If it's not 1, I think it's usually 2. Right, so this actually now gives me the right shape that it's expecting. I can just feed this one here. Hopefully that works. This is interesting because a while back I did try and run this and it was working okay. Let me just see if I can just quickly figure out where I went wrong. So running shape on X train, I'm getting back 7. We do this on Y test, Y train. So this is how the shape looks. Let me just add additional cell here so I can show you also. This is an numpy array. The shape is just similar to how you check a shape for a pandas data frame, because actually pandas uses numpy. So this just tells me there's 2,361 rows in 7 columns, and here it's just a single row. I think I basically need to do a reshape on this. hopefully to 1, -1, then do a shape. Okay, hopefully that actually fixes it. But I don't think so, because in this case I would have expected it to be more it's a softmax, so basically a softmax is either going to be on and off. So let me just see if I can quickly figure where the issue is and pick it up from there. Okay, so one thing I actually did see is it's possible to actually use a revert to checkpoint from Jupyter, which I actually opened up as this, and it has the same logic and it works. Okay, so I'm just going to be use this if actually it doesn't work out up to that point, but let me just try it one more time. I'm guessing maybe the issue is I actually skipped this part. So just run that, run this, and run that. Yes, so yeah, I forgot to click that part, and that's where that happened. So this is just how you basically define a model, saying model dot sequential add dense layers. I'm actually not going to go too deep into how models are designed at this point. So loss, categorical loss, which is just a categorical way of classifying errors. Though I could have used binary categorical loss, which is either 0, 1 and something like that, yes or no, which is just dividing into 2 sections. But either way it works okay. And monitor early stopping basically is checking for has the error at a certain point dipped. Well, basically has the loss, basically this is, as you can see here, there is loss and value loss. So what the model is mainly interested in is in getting the loss as low as possible, but it can do something which is usually called overfitting, and whether it's finished running, which is when it's working so hard to make the loss go down, but the value loss, which is the out of sample, the test value, the error starts actually going up. And if I just scroll here slowly, you'll see it's starting at 5. Usually the loss is lower than the value loss, and you can see as it goes down, both of them are going down, and as normally that the loss is usually lower than the value loss, except for this particular moment where it seems okay, let me just see what this is trying to tell me. The profile has changed on this essentially. All right, okay, so let me just close this. I think this is the one that's fighting to override this one. So with this particular moment, I'm not sure why, but it really got good at the value loss. Dense layers are usually pretty interesting in that scenarios. In that way, they can have if I was to plot this, you'd actually see there's a little bit of jaggediness in it learning how to learn, and at a certain point it realizes, using that early stopping method, that the value loss is actually going up. And when it does that and it's not been going down for a while, it just stops and uses the best model that he got using this checkpointer, which basically just saves the best model at any particular model as best weight.hdf5. And so when that is finished, that one is loaded here because you just use the same name. Now you have your model that was the best at any particular moment here. You could say that that model may be the one with 0.6 at a certain point, not saying that it will get 0.6 at all of them, because I believe epochs means that it actually divides the data into certain sections, like batches, and then works with the batches. Maybe not, because they are batches and they are epochs. And basically, with that in mind, the model is finished and it's running. So let's move on to the next thing, which is showing you how the model looks like. First important part is to make sure you save that and do a prediction with the model using X-test. Then if now here I'm just going to print the shape of the prediction shape, because it usually comes back as a numpy array. And if I print prediction, which is the shape is up here and the prediction is down here, no, this is the shape at the top, so it's 591 by 2, and at the bottom you can see which is this the prediction values. And to get your answers as a yes or no, here you can see this is something that I found actually that does that, is using npend or argmax. It just gives you the value that you're looking for, which is either 0 or 1, and here's the list of predictions and the expected values. It's hard to actually match them up because of how they are arranged in this case, but one cool thing is the last thing I did here is y arg test is npend or argmax, y test aggregated is np argmax y test x is equals to 1, and I can take that, use it here as getting the accuracy is y test aggregate with the predicted class, so I know what the answers should have been and I know what the answers it's saying. So basically accuracy is called just compares the two lists, how many of them actually match up, and you get a 92% accuracy, which is good. It's almost as good as the other one at the first try. And here you can see I wanted to show you now, if I try and did this with another model, see what's going on here. So df2 drop, I wanted to now use the second data frame to run on exactly the same thing, and it seems, yeah, it's already been dropped, so yeah, there is no need to drop the head again. So here I'm just doing the same x and y division, creating a prediction, getting the prediction values, saving the prediction values, seeing the second accuracy score. So it's now dropped to 59%. So deep learning models, unlike random forest, don't generalize pretty well in this case. I can also try it with another model, just to, as a final model, just to show you how it looks. So this one got just, I think I may have browsed over that, it got 49%, which is here, accuracy. And yeah, so basically the accuracy with this tends not to be as volatile as as stable as you'd expect moving from one thing to another. How I'd put it in this case is, if you think about it as dealing with stocks as playing poker with someone, and one of the more important things with playing poker is, because you can't see the cards that the other person is holding, you're going to actually have to see telltales of how they're acting. Like, do they look a little bit scared, hesitating? So people usually, I guess, who play poker more on a professional level read the people as much as they read their cards. So in this case, you can say deep learning models put a lot of effort into reading the data, and when they see data in a different sense, the body language in quote unquote are not the same, so it gets worse a prediction. Okay, so thanks for watching, and this is the end of this video.